Hello everyone and welcome to the walkthrough for worksheet 6B. 6B is going to be kind of just more practice off of what you were doing on 6A. A lot of law of sines, a lot of cosines. If you didn't write those down or take a picture of them last time, here's law of sines and here's law of cosines. So looking at this worksheet, we're going to be doing numbers 2, 4, 8, 9, 10. So there's a bit more of a push on this worksheet for some real world examples, and that's kind of what the end of the worksheet's about. So let's start with looking at number 2, and then we'll do the rest. Okay, so number 2 says they gave us an angle and a couple sides. So if you draw a triangle, which I did over here, we have side, angle, side. You can't really do law of sines until you have a side length and an angle across from it. So at the beginning of this problem, you can't use law of sines until you find that third side. So this one, you have to use law of cosines at the very beginning. So I take all the stuff I'm given, I plug it in here, and I'm solving for this red A right here. Well, on the right side, if you plug that all into a calculator correctly, you'll get 358.08. Square root both sides, you get 18.92 inches, and that's the third side. Once we have this third side, we can use law of sines, and that's what I've set up here. It's across from the angle 39, so we have sine of 39 underneath it. I solved for the angle B first. If you do this correctly, you should end up with 45.49, and make sure your calculator's in degrees. And then from there, I know two angles, so to find the third, I know that A plus B plus C equals 180. So I know A and B. Solve for C, and you end up getting 95.51. Okay, pretty straightforward on that one. Okay, let's look at number 4. Number 4, we have just 3 sides. So this is kind of like one of the ones from the last worksheet. You have to solve for that missing angle, and you have to use law of cosines in order to do so. So I plug A, B, and C into the formula, and I kind of ran out of room. That's why there's this arrow here. But then we have cosine of A tacked onto the end. You have to be very, very careful the way you solve this. We're going to subtract the 4.7 squared. We're going to subtract the 6.9 squared. And then a negative 2 times 4.7 times 6.9, we divide that over to the other side. Inverse cosine both sides, and you end up with a positive 23.55. I would do that on a calculator a couple times just to make sure I was plugging that all in right, because a lot of people goof on that, especially on the quizzes and tests. Okay, so just to let you know there. We have this angle now, and so we have an angle and a side across from it, so we can start using law of sines. I solved the first one for angle B with this setup, and you get B equals 35.93 degrees. And then once you have two angles, you can always solve for the third by subtracting them both from 180, and I end up with 120.52 degrees on that one. Okay, let's skip down to number 8. So number 8 says, Miriam is flying from Salt Lake City to Denver. The distance is 500 miles, and she just got her license. So she's still getting used to reading all her instruments, and it turns out that after 2 hours of flying at 140 miles per hour, Margarita radios Miriam and tells her she's been flying 12 degrees off course. So now she's got to figure out how far she actually is from Denver. Well, there's a little bit of math with this. It says after 2 hours flying at 140 miles per hour, that means she's flown for 280 miles. It's just 2 times 140. Okay, so that's how I drew this picture here, and that's how I got this 280. So a direct flight from Salt Lake City to Denver would be 500. She's flown 280. It's 12 degrees off course. That's what we have. So for this one, we don't have to solve for all the angles and all the sides. All we need is the distance from where she's at to Denver. So for this, I'm not going to use law of sines because I don't have any sides and angles across from each other, but I can use law of cosines, and I can do it in one step and figure out how far off course she is. So I plug all of that into this formula, and we're solving for question mark. I didn't call it A, but it's really A. And if you plug that all into a calculator correctly, you square root it, you'll end up getting 233.49 miles. And that's what we get for number 8. Okay. Number 9 is a bit of a tricky, it's kind of like a vector problem. So it says you're flying a plane 250 miles per hour at a 20-degree northeast direction. So that's 20 degrees from horizontal. So that's how they have that labeled down there. The wind is blowing at 30 degrees at a northwest direction. So that's 10 degrees off a horizontal. Okay. What is the resulting vector? So on this picture, I drew this dashed line going from the bottom left up to the top right. That's what I'm looking for. The direction of it, so how many degrees off horizontal it is, and the magnitude. Okay, so magnitude is basically going to be the speed. So if you're going a certain direction and the wind's kind of blowing across from you, it kind of throws you off course, and that's basically what we have going on here. So I drew a simplified version of this triangle over here to the right. It doesn't have all the extra stuff in it. We have a length of 250, we have a length of 30, and then we have the angle in between. So we have side, angle, side. So we're going to use law of cosines. And the first thing I solved for was the missing side. So if you plug all this into a calculator correctly and square root it, you'll get 224.52. So even though she's going 250 miles per hour, she's trying to go 250, the 30 degrees is slowing her down. She's actually going 224 miles per hour. And that's because she has a bit of a headwind. It's not directly in her, against her, but it's kind of at an angle. Okay, so now the hard part here is we need to find the vector direction. So in this triangle that I drew, I have this red X. So what I'm going to do is I'm going to solve for that red X, and I used the law of sines to do that. 30 is across from it, and then I used, 30 is across from the 224 we just found, and then the side length 30 is across from this red X. Well, if you do all this correctly, inverse sine it, you get 3.83 degrees. Well, that's the red X angle, and then I'm adding it to that 20 that they gave me at the beginning because it has to be off of horizontal. It's not just inside the triangle, it's off the horizontal. So 20 plus the 3.83 degrees, we get 23.83 degrees northeast off the horizontal. So that's how you get that, okay? Let's look at number 10. So number 10 is a really cool problem because you could actually do this if you wanted to. It says one mountain climber, Jaylene, is 21 meters directly above her best friend, Fadlia, maybe, on a vertical cliff. They each throw ropes down to a third person, Brianna, girls' day, rock climbing fun, who is standing on the ground below. The rope from Fadlia is 34 meters long. The angle between the two ropes in Brianna's hands is 8 degrees. How high is Fadlia off the ground? How high is Jaylene off the ground? So I drew this picture. Oh no, they drew this picture. I just labeled it. It says the rope from F to B, so Fadlia to Brianna, is 34, so I labeled that. They said Jaylene is 21 meters above Fadlia, so I labeled that. And then the 8 degrees in between the ropes is that angle down where Brianna is standing. So what we need to do is we have to find the length of FA, and that's a right triangle, so that's nice. And then the length of JA. So we got two right triangles kind of within each other. We can try and use that, but what I used first was I knew the side length of 21 was across from the angle 8, so I used that for law of sines. And then I'm going to use 34 across from X. Well, I use that, find that X by setting this all up, and you end up with 13.02, and that's the angle up where Jaylene's hanging out. Okay, so I have two of my angles, and now that's a right triangle, so I could find the height of the entire triangle if I wanted to right there, and that would have one of my answers. But I chose to do it a hard way. Let's see how I did it. So your 13.02 degrees goes in here, plus that 8 degrees. So I'm solving for angle Y in there. You end up with 158.98 degrees. If I add that, or if I figure out what Z is for the top of my angle FAB, I subtract that from 180, you end up with 21 degrees. So I found angle X, Y, and Z on my diagram up here, and that's just to get both my right triangles. So now, I did use some right triangle stuff. There we go. We have cosine of angle Z, so I'm finding FA first, is going to be my adjacent, which is FA, what I'm looking for, over the 34. So if you solve that correctly, you get 31.74. And then they said that Jaylene was just 21 meters taller than that, so we add 21 to the answer we just found, we get 52.74, and that is it. Okay, so that is it for this worksheet. Worksheet's pretty straightforward. I think some of the word problems are kind of tricky in the way that you have to draw them, and they're just, I don't know, they're kind of convoluted with the vocabulary and stuff like that. But overall, I don't think the math's very tough on this one, so hopefully you agree. If you have any questions, feel free to email me, and I'll see you in class.